Good evening, everyone. We'll wait a while, about 2 more minutes, and have more people join, and then we can start. Thank you. Good evening once again. So, this is just a reminder for all our members to follow us on our handles: LinkedIn, Facebook, WhatsApp, Telegram, IIPGH, for all announcements and upcoming events. Also, a reminder that our ongoing coding for kids is happening every month. We should register awards for them. That's an upcoming coding caravan um, in Sugakope. So all those interested should just register for them, to register to attend. Also, we have an ongoing professional consultancy services that's available to all who are interested. For you to be a member, kindly visit iipgh.org and follow the link to be a member if you wish to join, if you are not already a member of IIPGH. Thank you for your attention. Good evening, everyone, once again, and welcome to today's webinar on satellite internet and the regulatory regime in Ghana. This webinar is proudly brought to you by IIPGH. My name is Christabel Buko, and I'll be your moderator for the evening. As we all know, as we continue to navigate the digital landscape, satellite internet has emerged as a vital component of our connectivity ecosystem. However, the regulatory framework that governs this technology is still evolving. Today, we'll delve into the opportunities and challenges of satellite internet in Ghana and explore the regulatory environment that shapes its development. A panel of experts will share their insights and experiences, and hopefully we'll have a very lively discussion to unpack this complexity, the complexity of this critical topic. So let's get started. To commence with, permit me to introduce our guests for tonight. I have two fine gentlemen here, Dr. Roland Yao Kudozia and Mr. Charles Dazi. Dr. Roland Yao Kudozia is a senior researcher with the Gidet Institute, as well as the head of licensing at National Communications Authority. However, he is not here representing the NC on this forum. Roland Kudozia is a seasoned telecommunications expert with extensive experience in regulatory framework, quality management, and training. He currently serves as the head of the licensing unit at Ghana's National Communication Authority, where he develops new licenses, drafts service definitions, and provides guidelines for new telecommunication services. Roland is also a lecturer at the ITU Academy, a deputy regional manager at NTA's Greater Accra Regional Office, the senior research fellow and telecommunication tutor at Gidet Institute. His previous roles include managing laboratory operations, overseeing standards and technical regulations, and working as a core network engineer for Huawei. He holds a Doctor of Science in Computer Science from Aspen University, along with several degrees and certifications. He has presented at international conferences and authored publications on knowledge management topics. You're welcome, Dr. Kuduzia.
Thank you very much, Christabel.
Thank you for coming. Thank you for coming. Charles Dazi is also a technical manager at Galaxy Aerospace Ghana and holds a degree in mechanical engineering with specification in mechanics of machines and aerospace technology. With 9 years of extensive industry experience, Charles brings a wealth of technical expertise and insightful innovations to the discussion around satellite internet in Ghana. Charles, you're welcome.
Thank you very much. Thank you very much.
Thank you. So to set the ball rolling, we'll take a presentation from Dr. Kuduzia, and then we'll continue from there. Thank you.
Thank you very much. So I will share my screen. Please, I hope you can all see my screen.
Yes, we can.
Yes, please. Your screen is visible.
All right. So thank you very much. I'll go straight to the topic for today. So satellite, we'll be looking at the background on satellite technology or communication, and then we'll look at the regime in Ghana. It would have been better if we were able to look at other African regime or elsewhere so that we could have a broader view. But as the time will not permit, we just limit ourselves. So we've always heard about satellite internet. What is it? It's just internet. It's just that the medium in which is being delivered or the technology for delivering internet access is different from what we know it to be. So satellite offers broadband internet, unlike the narrow band where we have a smaller bandwidth. And it also it provide wider access to people and terrains where the traditional terrestrial network cannot cover or is not feasible to cover those places. It's as a result of our ability to use satellite to communicate. That is how come we are able to use it also to provide internet access. So the in satellite communication, it's just the use of satellite to relay information from Earth to space and back to Earth. And the key components when we talk about satellite communication, just essentially three. Uh, just the satellite in space, your ground station here on Earth, and a transponder to as part of the satellite to receive signal, amplify, and then retransmit it, the signal. Because the distance between the Earth station and then the satellite in space is quite long. We have to make sure that the signal that is received or transmitted is amplified and before it's sent back. So now we want to look at some few things, how it works. First, we have a ground station. I will just show a picture on that just a moment. Then we also, the ground station does the uplink. That is, you send a signal from Earth to the satellite in space, and then the transponder will just receive signal, amplify, change its frequency to just to avoid interference with the downlink frequency. And then once that is done, the signal is beamed back on Earth, and then we, with the help of other devices, we're able to use it the way we intend to use it. Now, when it comes to applications of satellite, it's so broad, but just to limit ourselves here, we use it for telecommunication applications. So we have satellite phones, that you can use anywhere on the planet, as far as there is a footprint of the particular provider you are using. And also we have satellite television services, and these are key for especially in areas that are hard to reach with the traditional terrestrial services. And it's also used for TV broadcasting and then navigation system. So we have the global positioning system that I use. It's so key. It's so important to so many applications. Whether it's travel by air, by sea, or even by land, these systems are critical. So GPS rely on satellite communication to provide accurate positioning information. And then we also have application for weather forecasting. With this technology, we're able to study weather patterns and then know how clouds are gathering and predict where and when there's going to be weather changes, weather rainfall, hurricanes, and so on and so forth. And then it's also used for secure and reliable military application. So if you could, if you ever heard it during the time that Russia invaded Ukraine, the Ukraine military were heavily relying on Starlink satellite system to be able to communicate. So that's one application. It's used by military all over the globe. And then the advantages of satellite communication is that it can cover very vast areas, including remote locations. So much as the traditional terrestrial network is so limited within the space where we can either use microwave links or probably lay fiber or copper to reach. Satellite comes in a different way. Once it's hung in space, it's able to have wider coverage, which we normally call the footprint. And then it's reliable in the sense that it's less prone to disruption compared to the terrestrial system. You hear of terrestrial fiber being cut, copper being removed, and so on and so forth, disrupting communication. And also is scalable in that you can add more users to it without necessarily changing the infrastructure. Where I'm coming from, when you have to make sure that there is to cover more people or even to accept more traffic, what you need to do is to do significant changes on the network, increase resources to just to make sure that you can take more people. So you need to plan ahead and be able to add more. But for satellite, it's easy to just add on. You don't have to do much changes on the infrastructure. But this type of communication is not without some form of a deficiency. Uh, One is that the latency, the signal, the time it takes for transmission to happen can be longer than the terrestrial systems, uh, especially in geostationary satellites, because of the distance the from Earth to space and back. What we call the round trip latency is high, and then the cost, initial cost for launching satellite and even maintaining it is so high. And even when it comes to terminals for satellite terminals are also expensive, especially if you consider our our economy. What our in terms the Ghanaian economy is so high. So then, but the satellites have specific characteristics in that it has multiple access capability. I mentioned that you can have point to point or point to multi point or multi point to point connectivity in especially for dense or small to medium density scattered areas. You can have that covered. And then in terms of distribution, you can use it for point to multi-point distribution. That's including a television broadcasting and other multimedia application. Then in terms of data, is for data distribution for business, internet broadband services, or ubiquitous broadband connectivity or moving platforms such as ships, aircraft, trains, and then vehicles. Excuse me. For most, for now, some aircraft even offer internet services while it's in space. Earlier on, things were not like that. It was strictly you just have to turn off your Wi-Fi during the entire trip and so on and so forth. But with the advances in the satellite space, now they're able to offer internet whilst in space and also ships. Well, there's no way you can provide terrestrial services on ship unless it docks at a nearby port. Even that is a little difficult, but satellite makes these things possible. And also, we can also talk about the flexibility in terms of changes in traffic and network architecture, with and then the ease to put services, to put terminals or satellite in operation. When someone requests for a service, satellite service, it's not like now let me go and check whether there is a cable connection or not, what they call survey. But once a satellite has a footprint, it's there anytime there is the need to add on a service or provision a service is easily done. Now let's look at the infrastructure end to end for satellite network. So we have the satellite itself, and the satellite itself it comes in three flavors. You have the geostationary satellite, and then the low orbit satellite, and the medium orbit satellite. So for the geostationary satellite, they are positioned approximately 35,000, almost 36,000 kilometers above the equator of the Earth, and they remain fixed relative to a point on the Earth's surface, providing consistent coverage over large areas. Uh, in actual sense, these satellites appear to be stationary, but they are moving at the speed of the Earth. The way the Earth is rotating, that's how fast they are also going. So it appears to be fixed. And then we also have the LEO, which is located from 5,000 to 2,000 kilometers above the 500 to 2,000 kilometers above the Earth, and they move in orbit and provide low latency and faster speed, but require constellation of satellite in order to maintain it. So you don't, because it's very close to the Earth, the area of coverage is limited. Unlike the geostationary satellite, they are far. So think of it this way: you have a torchlight. When the torchlight is close to a wall, the the way the beam that is coming from the light is limited. It covers just a smaller area, but very bright. So take the brightness to be the latency. And when you move it away, far away from the wall, it tends to cover a very large space, but the brightness dims. So that's in relation to the latency. Take it like that. So the closer you are to the Earth, the better your round trip. You're able to travel faster. And then we also have the MEO, which is the medium Earth orbit satellite, which is between 2,000 and 35,000 kilometers. So just between the LEO and GEO, we have the medium Earth orbit satellite. Okay, they also it's just a compromise between the LEO and GEO. Now, when you look at some of the terminal equipment like the recent iPhone 14, 15, they are all equipped with LEO, so that if there is any provider, you can just switch. You can just use your iPhone device as a satellite receiver. Then we have the satellite dish, which is installed at the user's location. So the dish is the one that receives and transmits signals to and from the satellite in space, and it needs a clear line of sight to the satellite. So normally you have some of these professionals trying to locate a particular satellite with the positioning, and then so that they can align the dish. And some of these you see it for television application. You see it a lot all over. And then beyond the satellite dish, we also have the router or the modem, which is connected to the dish via cable. And then the modem is now connected to your terminal equipment, like your computer, tablet, and so on. So these are the ground equipment. Then we also have the gateway station. So the gateway, there are large antennas and related equipment that connect to the satellite. These stations act as intermediary between the user's dish and then the broadband internet network. And then beyond that, we also have the network operations to be able to a center which look at the information on satellite, whether there are issues, monitoring and performance, traffic management, and so on and so forth. So so normally, then let's go to the backhaul before mention what I want to say now. Then the backhaul network has to do with the fiber optic cables, data centers. So the fiber optic cable will now connect to the ground station, and that is the one that's going to feed it with the internet, the global internet backbone, and providing high speed links to internet services, and then your ability to pull or store content online. And then, of course, data centers to store and process data, and then hosting service and application that can be done via the internet. These are all centered at the backhaul. And then we move to the user equipment, which includes the satellite dish, modem, router, and any connected devices. So the user equipment is part of the ground equipment. Okay. Now, uh, I know there are some. I'll try to answer some likely to be asked questions. The question of whether when you disconnect the issue that we have in April in Ghana, where all the fiber coming, the submarine cables coming to Ghana were damaged. So, with satellite communication, would we be could we have still be able to access the internet when the issue happened? So the answer to that is yes and no. You know that the internet is not in space; it's on Earth. The satellites are just hanging in air just to provide coverage. They are antennas, large antennas to provide coverage. So whatever internet that we have cooked here on Earth, we pass it through the ground station, through fiber optic to ground station, and to then is beamed straight from the ground station to the satellite in space for coverage. So that is the issue about the access to internet and other applications. So this is just a picture for us to appreciate all that I was saying. So you have take a laser. So you have your satellite in space, and then you have your satellite gateway. Then you have domestic point of presence. That is the point where the satellite gateway is connected to the terrestrial network for fiber. So this for internet. So this one could be connected to the submarine cable. So an ISP or a telecom service provider could be the one to provide the internet services to the satellite providers. So in essence, they have to buy capacity to be able to do this. Okay. And then so the customer as a customer, you just access, it's just a normal radio frequency communication. You send it, you beam through space through your satellite dish, and then once it gets into space, it is relayed back to Earth through the satellite gateway, then from the gateway forth and back. So it's just a cycle of activities, what we normally do. This is just another picture just to provide more clarity. but this time it's the LEO antennas that is being used, LEO satellites. Okay. Then let's look at some the issue on latencies and then speed and cost. So when you take, so in the table as you see on screen, I have the type of satellite, and then we talk about the download and upload speed, and then the latency. So when you take a geostationary satellite, you can have between 12 to 100 megabit per second for the download, and 3 to 25 megabits per second for the upload, and a latency of 600 to 700 milliseconds. Okay, so the kind of latency that is experienced with satellite communication is high as compared to terrestrial network. And then for the LEO, because it is closer to the Earth, we have um, the bandwidth or the speed, the download speed is a bit higher than the geostationary. Okay, so we have from 50 megabit per second to 500 for download speed, and upload speed of 10 megabit to 50 megabit per second. And then you could see that the latency is quite better as compared to the geo. And then the MEO is a trade off between low orbit and geostationary orbit. Okay. Then let's look at factors that affect latency. First, it's an RF communication. So we have the issue of weather condition affecting the signal strength and quality. So this one can lead to lower speeds and higher latency. And then we have the issue of network congestion. High demand and a large number of users can result in slower speed, especially during peak usage times. So it's no different. The issues that affect the normal communication is no different, apart from for fiber optic communication, it has a different flavor on its own. But when it comes to um, satellite communication, there are things that affect it, weather condition, network congestion. And then one thing that should be taken into consideration whenever we are talking about speed, latency, has to do with the equipment quality. So you have terminal equipment. Several, you see that there are several equipment that are coming, but let's exclude the provider's network from the user's terminal. That is either your phone or your laptop, the modem you are using, if it's coming from a different provider. If the equipment is not quality, it can affect the quality of service that you receive from the service provider. And of course, then your pocket, the plan that you have subscribed to can also affect your data speed and then the latency. So the more you pay, the better the service that you can enjoy with satellite. And this is just to provide clarity on the LEO, MEO, and the GEO. And then you see the differences in terms of the MEO. So in terms of the latency and speed. And then we provided some of the satellite providers that we know. We have OneWeb, SpaceX, and the Amazon, who are at the low Earth orbit. And then we have the MEO, which is the SES provider, and then O3B, then the Geo satellite, we have Viasat, Imasat, Hughes, and the Intersat. So these are far away from the Earth, about 30, close to 36,000 kilometers away from the equator of the Earth. So this is what we have. Now let's look at some of the costs. So I tried to find some costs across in Europe and Africa, just to make a comparison for us to see what's really happening, the flat fees. So when you want to use subscribe to satellite internet, depending on the provider, you are paying something as little as, for Africa, as little as 30 US dollars to, and as high as 150 US dollars as a monthly cost. And then you can have a speed ranging from 12 megabit to 50 megabit per second. And for some of the providers, there are data caps on it. So for Viasat, for example, you have between 40 GB to 200 GB. And beyond this, you have also the installation cost that can range from $200 to 500. And the installation cost is that is if it's a professional who is doing the installation for you, that's how much they can charge you. But the device, the equipment cost may add up. Okay, so you see for Europe and then you see for Africa. So in Africa, we have some of the providers. We have Viasat, yeah, Click, and then Connect Africa, Avanti Communication, and we also have same Viasat, SES Broadband, Utisalat Connect, and then SpaceX. That's Starlink also in Europe. Though Starlink has started a operation in some African countries like Benin, Nigeria, um, Kenya, and then some of the Southern African states. Yeah, this company is still going through regulations, trying to regularize their operation in order to continue operation. So I did some, made some checks on how much our folks in Benin, just 2 countries away from Ghana, towards the east, how much they are paying. So for Benin, they are paying close to $49 as a monthly subscription fee. Okay, so you can just multiply that by roughly 15 CDs, and then you know how much they are paying is for CD equivalent. And then the equipment cost, the cost to acquiring the dish, the router, and then the modem. Uh, so before you can connect your end user device, your laptop or whatever your equipment is around 650 US dollars. Additionally, for Benin, the users pay $5 to the regulator in Benin. The regulator in Benin is the ASEF. Then in Nigeria, they are paying monthly subscription of $25. Initially, it was high until somewhere this year that they slashed the price to 25 US dollars. And then the equipment cost is now $290. Please note that earlier it was around $650 when they started, but there's no any additional charges. Where we have the less in terms of cost is Kenya, and that's for the installation, the equipment cost. But for monthly subscription in Kenya is a bit high. 50, they are paying close to $51 and also pay close to $70 for the equipment cost. Earlier, again, the prices were very high, but even this particular one, this is for SpaceX, Starlink's pricing in these countries. Um, they were doing promotion, so some of the prices still came down. It depends. Businesses always do promotion for some of these, but these are the initial prices, non-promotional cost to this. Okay. So that's about the satellites and all those things. So now let's look at in Ghana here, what is this? How is the situation like? Okay, so please note that internet internet services did not begin in Ghana just because yesterday. I mean, when SpaceX came into the picture, we have had satellite internet services for a very long time in Ghana. Ghana used to have its own air station at Kuntrisi that was being operated by Ghana Telecom. Okay, and that was being used for international communication prior to bringing fiber, submarine fiber to Ghana. We were using satellite services for internet, for voice services, the data services, and all the services that you could think of. So this is not a new thing. It's just that in this dispensation, the services have been made better. Now the technology has been improved to allow for bigger bandwidth and for it to be able to provide better service. Earlier, the round trip was also very high, so they were using the geostationary until the LEO a lower orbit was also introduced by the new breed of satellite operators. Okay, so this has been the situation uh, before fiber optic came in. So the licensing of satellite service providers, these are the various licenses that we have. We have spectrum license generally, wherever you want to operate. And then you have a launch licensing, landing right, and then satellite operation licenses. So when we talk about the spectrum license, has to do with the fact that spectrum is a very expensive commodity. The major cost of communication, acquiring license from any regulator hinges on how much they are willing to auction spectrum to you. So satellite operators need license for their communication frequencies, which is so the frequencies are regulated at two levels, national and international bodies. This is to prevent interference. So there's that kind of coordination that is done among the countries or the administration for each country. So before you want to launch, you have to make sure that you inform every administrator where your footprint will cover. So in Ghana here is the National Communications Authority. And then when we talk about the launch licenses or the operator, you before you launch, you need a launch license from the country's authority to ensure compliance with safety, environment, and regulatory standard before launching satellite in a particular uh, uh, administrative area. And then and then if you want to land your satellite, then you also need a landing right, which is the permission from each country to send and receive data via satellite. These are crucial for operating in national market and require coordination with local telecom authorities. So, but when it comes to the launch, it's a coordinated effort. And also the spectrum acquisition is also a coordinated effort. And at the international level, it is led by the International Telecommunication Union. An office called the Radio Bureau is responsible for this. And then for the satellite operations, you need to acquire a license to ensure compliance during compliance with orbit, frequency regulation, and then the orbiting when you have to remove satellite from orbit. This also to ensure that there are less debris in space. The amount of satellites that are dead, that are orbiting around the Earth are a lot. And the bodies responsible, there's now a worry as to how to clear some of these things from orbit. Because quite recently, some of them fell from space and it landed somewhere in Australia. And then, so they keep coming down. But the good thing is that when a satellite is falling, free falling on Earth, because of our atmosphere, before it gets on the ground, most part is already bent. Okay, so these are the various. So to get the licenses of satellite service providers, it enables you to get a market access authorization. One, operator, you may require specific market access authorization that comply with local telecom, like the way Spaces, OneWeb, and others want to operate here. They have to make sure that they comply with specific regulations in Ghana. And then you are also required to have international coordination. And as I mentioned, is the ITU. ITU is the Telecommunication Union. It's an agency of the United Nations responsible for telecommunication. Okay, so the ITU develops standard and ensure that there's a global access to telephony services and beyond. And also, the licenses also ensure that you comply with regulatory requirement. Let's look at the some aspect in Ghana. Okay, so Ghana, I mentioned that the National Communications Authority is responsible for regulating the the electronic communication space in Ghana. So, and then the Ministry of Communication and Digitalization is responsible for policy. Okay, so the policy that the government set to go through the ministry, and then the NCA will ensure that there are proper regulatory framework to deal with those or to ensure that the policy is implemented. So these are in Ghana, this is how the satellite system has been, the license, the regulatory framework has been designed. We have the space segment satellite services, and then we have the Earth segment satellite services. So for the space satellite, space segment, we have the satellite filing. So you can file if you now want to launch, have a new set of satellite. You need to file with the ITU. So in Ghana here, you can do it through Ghana file, and then the NCA will be responsible to make sure that it is filed with the ITU, and then the ITU will also inform all the other administrators. Okay, so then you also have the satellite landing right for fixed satellite services. Okay, and then landing right, satellite landing right for non-fixed service. That is, we also, the non-fixed is also called the MSS, mobile satellite services. Okay, then when it comes to the air segment satellite service, we talk about the satellite air station terminal, then the gateway satellite air station, then satellite air station network, then portable satellite terminal and air stations in motions. Okay, so I've mentioned most of this. The air station motion are normally put in moving vehicles. So vehicle, I mean ship, aircraft, and then in areas where we have intercontinental trains, that is, for example, like you take the ECOWAS region, uh, assuming we have fast trains moving from Accra to, say, Lagos or Abuja, or from Lome to La Côte d'Ivoire. Some of these things are installed inside because, number one, we can use it to access the internet. You can also, it's also used for navigational purposes. And then the portable satellite terminals are handheld device that you can carry it around. Okay, and then for in order to access satellite services, then the satellite air station network allows you to be able to provide certain services in a particular geographic area. Then the gateway allows is the one that will now connect to the satellite in space. So to put up a gateway, you need a license to do that. Okay, and then the satellite station terminal is too. Now, in the as we go, I've just explained them in detail in the slides. So for the satellite landing right, which is for the fixed satellite services, it allows service providers the license allows services to be provided for NGSO, that's the geostationary, non-geostationary terminals on board foreign registered aircraft and vessels while passing Ghana's airspace and territorial waters in the license frequency band. So for this, the landing right for, for fixed satellite service, this is it. But this license does not permit space segment operators to retail their services in Ghana. For example, OneWeb or um, Starlinks cannot, if they have this license, that they cannot provide services, normal internet services to people in Ghana. Okay, you can only do that by going through. Yes, please. Isabel,
Not
your
to,
hand is up.
yes, yes, Doc. Not to cut you, but the Starlink, I was just wondering, which of the infrastructure, is it the GeoLeo or the MEO that they will be offering?
It's the Leo. Earlier, can you see the screen? So SpaceX, they are providing the Leo. So they
They are
have a
providing the
constellation.
Leo.
Yeah, so they have a constellation satellite that is enable them to cover larger areas. Okay.
Okay.
Yeah.
Would like to have some questions. If people have questions, they can raise their hands, and then we can be taking the questions as we go. Thank you.
Okay, so let me just complete this particular slide and then so then I also mentioned we have the satellite landing rights for non fixed services. So this particular authorization grants the right to a space segment satellite operator in all satellite services other than fixed satellite services, including but not limited to satellite systems in navigational, edge orbit, edge observation, remote sensing, and broadcasting services. So there are a ton of services that you can use this satellite to do to provide. And in most situations, when you want a license to operate, you need to be uh, provide the details of the services that you want to provide to a national regulator so that they can provide you with the appropriate licenses. Okay. I saw a hand up from I think one Alfred or something. So please you can come in.
Okay,
Okay,
thank you
so
very much. My name is Alfred.
okay, okay, right.
Um, my, my question is, I'm a satellite installer, but I once had some discussions with some people that most of these domestic satellite that are paid access, this encrypted satellite. I don't know whether you can hear
Yeah.
me.
Yes, I can hear you, please.
Hello, can you hear me? Yes.
Yes, please, I can hear
Because
you.
they
Go ahead.
provide, okay, before they provide data like the TV services or online for a fee, we can actually convert them into providing internet service. I want to clarify from you how true and how possible is this? Thank you.
Okay, thank you very much. So the satellite can provide all those things. It's just the way the configuration and then the kind of facilities in terms of the infrastructure that they have. So the same satellite that is providing the TV, their channels that they are providing, they are bearers. So if it's configured to be able to provide television, internet, it means that they should have access to the internet through their gateway in order to be able to now provide and then the needed terminals to be able to do that, as I mentioned. So the fact is it's no different. It's just about configuration of your system to be able to provide that. If they're able to provide TV, they can also provide the internet services. Okay. I think we have
Thank you.
yeah.
I want to come in here
Okay.
to Charles. How does it look like if you want to implement a DAS? I'm trying to picture how it's going to work, how the infrastructure is, if we need connectivity in a room or something. If Charles could help us with that. Thank you.
Okay.
Hi, good evening, Christabel. Thanks very much.
Good
Um,
evening.
yes, before I answer that question, let me touch upon what Doctor said with regards to the question that was asked by the gentleman requiring. I think he was asking if the TV, sort of the dishes, the satellite dishes, can provide internet as well. Um, I think the only issue with the TV dishes is they can't upload. With the satellite dishes, they also upload. TV dishes are receivers. So when they receive the signals from geostationary, they then that is why they are usually kept. So then they send it to the LMB, and the LMB provides you with your pictures and all that. But they can't send packets of data. That is, they can't really upload data back. So it becomes difficult to use them sometimes, because you would also be uploading stuff, and then you be sending that means you're sending packets of data. So it becomes quite difficult to use them comparatively to Starlink. But probably if you want to talk about Starlink, or you want to talk about some of the dishes that are provided by the internet service providers, basically that. Um, but to your question, Christabel, you were talking about if you are inside, how you get the internet, or how do you want how is your question, please? Like, please.
I'm wondering how a DAS infrastructure will look like, or would be like.
A gas infrastructure.
A DAS, distributed antenna, where you have the repeaters indoors. If you need
Right.
repeaters for them also, or you need the receivers separately, or you need to link them with fiber. I'm trying to imagine how that installation will look like.
And that is regards to the satellite internet.
Yes, please.
Okay,
Charles,
so
if I may help with this one.
right.
Okay, yes, thanks. See, we need to separate distributed antenna system from the satellite communication. Distributed antenna system are terrestrial, are part of terrestrial network. It's just to make sure that in high-rising buildings, or buildings where there are a lot of tenants and who cannot receive the external signal, we find a way to put these antennas inside. We see them small like that, placed inside the building, but we feed them. Either you are, yeah, and most the way we feed them is not, in most cases, is we use coaxial cables to power, to send the signal in and out. They are RF cables. Let me use the right, it's RF cables that are used, but they are also connected to a station which allows the external, for them to exchange signal externally. Okay, so in any building where the quality of service inside the building is difficult, that what you do is to put the distributed antenna system inside the building. That is one application of the and so if you want to use the satellite is just out there in space. You find a way. Maybe you have a modem. Then you can connect the these antennas to that modem, so that you can have access to the internet or whichever service you want to have. Charles, you may come in, please. Just to add up.
Yes, Doctor. I think sometimes when you come at the back of a very strong presentation like this, it's quite difficult to add up, because you sort of encapsulated everything, and I think your answer was on point. So unless there's any other question, or maybe Doctor wants to finish up the presentation, and then I continue from there, please.
Okay, I still see Alfred. Alfred, do you have a second question, or it's still the same? Else, I have Charles Buffo here also. So Charles, is your question answered? Okay, I think Charles is fine now. You can lower your hand. Charles Buffo, please, you can go ahead and ask your question. Hello, Charles. Okay, Doc, you can please go ahead. If we get any more hand up, we'll just break briefly to ask.
All right, thank you very much. So we're on the type of licensing that you could have with a satellite, as far as satellite communication is concerned. So we also have the portables. Okay, which the popular one is the big guns. That's the broadband global area network. And some of these things are just small portable that you have, which connect to the satellite, and then directly, and you are able to have your internet services. I mean, through that. And then we also have amateur radios that are also using the also that also come as part of the portable satellite, and then satellite IoT devices, among other things. Then we also have the satellite air station terminal license, and this one it just referred to any fixed air station terminal, including VSATs, okay, that are linked to a satellite system for provision of internet access and or activity or connectivity solution via satellites. Okay, so now the way the technology is now moving now, there are in my line of work there are others who have been providing TV services, and that they now want to add on, using the same system. It's just because for now, most of the system that you see, the hardware is software defined. So you just have to change some few things inside the software, and it will be giving you a whole array of services. So when you have one service there and you have very good hardware with software, you can just tune it and you have a lot of services that you can provide for the public. So this is one of the service, and with this particular service is categorized in the licensing regime. You can have private corporate network, the one, then you can have one for research purposes also. So depending on what you want, you can have a category of license that will serve your purpose. Then think the last on this category has to do with the satellite earth station network. This one permits operator to operate a nationwide satellite internet service. So particularly, we are looking at operators like OneWeb, we are SpaceX. This is the kind of license that to permit them to be able to serve you as an end user to have access to the internet. Okay. Yes, Christabel, I'm getting to the end of my presentation. So if I may finish this one and then you come in. So
Okay, thank you.
then yeah. So we have I was also tasked to look to provide some cost. So in Ghana here, if you want to have a landing right for fixed satellite services, the cost of acquisition of the licenses is 1,000 US dollars, and the duration is for 10 years. It's just that on an annual basis, you have to pay 10,000 US dollars as the for annual operating levy. Then for the landing right, it's also $1,000, but you don't have to pay any fee again. It's just one time, and it's for 10 years. Then also we have the satellite gateway air station, also 2,000. Annually you pay 20,000. And then the air station eSIM, you pay 2,500, and annually you also pay 1,500 US dollars, and it's for 5 years. Okay. So we have things like the portable terminal, the satellite air station terminal, and so on and so forth. So those ones, these are the fees, depending on it's been put in classes and depending on the number of terminals. There are some fees that you pay. For class one, you pay 2,000, and annually you pay 20,000. So satellite services come at a cost. Okay. And so before anyone want to operate in a particular market, they have to look at the cost. Not only this, and all this one goes into affect how much they should charge you as an end user, like at the retail prices. Okay. And you have the regulatory fees, then you have your various taxes. Ghana, you have to pay your CST, you have to pay other taxes, VAT, COVID levy, and so on and so forth. So by the time you are done with your cost, it means all these things be transferred to the user. So we are here to see whether the satellite service here in Ghana could be cheaper as compared to other jurisdiction or as compared to the terrestrial services. Okay, the other thing is that satellite services could have been a better option for us to cover the underserved or unreached areas. That's bridging the digital divide. But it's also imagine providing a satellite service to a folk in a rural area. How much can they pay for that services? So unless there's a intentional effort by government to make the cost of providing satellites cheaper, I do not think that we can use satellites to achieve that purpose because of the cost involved. Okay, so I'll share the slide with the team. I already have it with them, so they can, for the kind of the fees and other related things, you could look at it at a later time. And if there's any question, you can let me have it. Christabel, please. Thank you very much.
Okay, thank you very much, Dr. Kudozia. Kudodia. I have some questions in the comment section. So Constance Agbeko wants to know what is delaying Starlink from being fully operational in Ghana? So I'm sure, Doc, since you are from NCA, you can help us with that one.
Okay, I will try. It's not only in Ghana, so but so let me take it globally. When Starlink started, they were all over Africa, everywhere, selling their terminals. Okay, but so in Africa alone, they were operating in about 23 countries. But today, it's only 3 of them. Last time I checked, that they are operating. They have to be made to withdraw their services because you need to go through regulatory procedures. Much as we want the service to be up and running, you cannot jump the gun and then allow it to run. So they have to go through regulatory procedures. They have to obtain license, okay, and get licensing is not like because the name is there or the service is there, so you get it. It is a contract, and until the two of you, the parties involved, get to an agreement, and everyone knows his or her rights and obligations, you don't get to the end, and that is the procedure that I believe these guys are going through. Beside, also, you remember I mentioned that about the performance of the service being affected by the equipment. Their equipment has to be approved by the NCA,
okay,
or any other regulatory authority, so that they can perform. And now they also have to build their gateway here. So, which means that you will be receiving, your services will be localized here in Ghana. uh, they will take the broadband, the backhaul from any of the ISPs or the submarine service providers and feed it to their gateway. And so that and now they can start distributing their services and you can buy the service from them and also however you want to deal with it. So procedures must be followed.
followed.
And this is what I believe. Yeah,
Okay,
thank you.
okay. I'd like to know, are there data privacy and security considerations in the operations of patronizing satellite internet services in Ghana? I mean,
Yes,
for
of
the
course. So
satellite
all these
internet.
things, yes, all these things are part of getting license. Okay, cyber security, data protection issues, or your obligation to customers or subscribers, your obligation to the nation in times of emergencies and other things. So all these things have to be sorted out, ironed out before, so they are all catered for by the regulator. And it's not only
Okay,
here in Ghana. Everywhere that you are operating, you have to make sure that you comply. So all these things are part of licenses that are given to them.
okay.
Thank you.
Thank you too. So I'll give this question from Richard Kwame. Asamweni to Charles. Richard wants to know what type of license does one need to provide internet services, like Starlink, Ku and Car, and then additionally, what are the processes obtaining a VSAT license, fees and duration? Okay, I think I'm not sure if Charles can help us with, but I think it's more directed towards Dr. Kuduja.
Okay.
Wants to know the type of licenses and the fees for Starlink, VSAT.
I think in the slide I show that we have, so for them, now you want to have a gateway. You have to get the landing right. Okay, so you need that license. And then you need to get the gateway license. Now, then you
Okay,
need to have then you must have the
the
satellite
earth station.
air station license,
Mm-hmm.
the satellite network, the network license. Where did okay, this one, the satellite air station network license. So this is more like an ISP license in some jurisdiction. So you need,
Okay.
if you want, you need to depend on what you do, you need to acquire all these licenses. And these are the fees that I mentioned, I showed on my screen. Okay,
Mm.
so yeah,
I,
I hope that
I
is
see they are
answered.
all in US. I see they are all in USD though. So let's make
Yeah,
time.
yeah, because you are in the international space at this time of the day. And it's 1,000. The cost is 1,000 US dollars. So roughly that's in Ghana city today, that's 14,500, or roughly 15,000. Okay. The highest is the eSIM, which is 2,500. That's about
Mhm.
give or take about 42,000 or thereabout. Okay, so
Okay. Mm.
yeah.
All right. Um, Daniel wants to know, this for Charles. Are IPTVs able to do uploads since they use internet? Charles, if you can help us with that question. Daniel wants to know if IPTVs are able to do uploads since they use internet. I think that's quite general for IPTVs.
Yes, thank you very much. I think when we go telecom technical, I have my colleague here who will who will help with a bit of explanation when it comes to fully telecom questions. I would take care of General Starlink and the space reality. But as far as I'm concerned, yes, and it's interactive as well. Uploads usually are from the dishes from that's sort of the internet dishes, the satellite dishes thing. From where I stand and from what I know IPTVs do not do uploads. From where I stand and from what I know, they do not do uploads. So that's a direct answer.
Oh, okay. Thank you. I have Daniel here. Daniel, I'm going to unmute you to ask your question. So, sorry, David. Sorry, David. So, David, please go ahead. Hello, David. David. Okay. If David is not ready, Alfred, you can go ahead with your second question.
Okay, thank you very much. there are actually some few questions. The other one is one. I have there are service providers that sell their cable modems. So if I track any satellite and I'm able to log in or connect that satellite to a cable modem and log in to that service provider site, can I access internet service from that place anywhere I am without necessarily passing through NCA? That is one. Then, like Doc was saying about the Starlink issues, I realized that Starlink they had some project and they were installing their devices in some places, but as a result of licensing, they will have to stop. But from now, what happened to those projects? Are they still coming back, or has NCA granted them the permit now, or what becomes the fate of those items? Thank you.
Okay, I think Charles would answer that one. And after Charles, you can go ahead and give us your slides. Thank you.
Yes, thank you very much. I think this one also has to do with a bit of regulatory body answering. So, Christabel, I think I'll let Doctor answer this. When it comes to regulatory questions, I believe Doc is the best person to answer it. I'll take care of the technical aspect, please.
Well noted. Doug.
Oh, okay. Yes, please. If okay, so I can only catch up with the last question, so he may come up with the first one. So um now they are in the process, okay, for most of the licensing and other approvals that they require, still in the process. Okay, so it's not that they are going to abandon the project. In fact, it's very active and it's ongoing. So I believe that at the appropriate time, when all the dots are connected, you hear them again on the market, and then you can have additional business to your current business. Okay. So can you repeat the first question that you asked, please?
Okay, so my first question was about we have service providers that the ISPs that sell their cable modems. Is that okay?
Yeah.
So let's say I go into the
Yes.
market and acquire a cable modem, comes home, connect, track any of the satellites and connect my cable to the cable modem. Log in because those
Mm.
ISPs they have their login details. Log into that cable modem. Can I have access to those internet service without having any issue with NCA and co?
Okay. So just like the situation before the NCA requested, another regulators in Africa requested Starlink to turn off the IDs in the particular jurisdiction. They were operating. So once you have your service with the satellite provider, and you have a modem, you are able to connect to the particular satellite, you'll be able to provide the services. But now, if you purchase a Starlink device in, I think, Ghana, Zambia, Zimbabwe, and other places, it will not work because they've been instructed to turn off the device IDs in those locations. Okay, so other than that, uh, it will be working. Let's take. You remember that I don't know since you are in the installation space. At a point, DSTV was very expensive, so people preferred to purchase a modem from Nigeria to come and use it in Ghana, and it was working until latter time that they decided to start blocking those device IDs that are meant for the Nigerian market, but in Ghana. Okay, so because it's a satellite, and technically satellite have larger footprint. So one satellite that is large could be, for example, if it's a geo, it could be covering the whole of the Western Africa. And so if it's even meant for the Nigerian market and you purchase the modem then bring it to Ghana, it will be working until there is a regulatory restriction on the service. That is when you're going to have problem with the service. Yeah. I believe that is well answered. I hope.
Okay. Thank you. I'm
Yeah.
okay.
Okay. All right. Thank you very much, please, and thanks for the audience. Chris.
Okay, we'll hold our questions a bit. Charles has a few slides to share with us, and then we continue with the questions. Thank you. So, Charles, we can give you about 10 minutes to give us the
Yes.
slides, and then thank you.
Sure. Second, please. Okay, can we all see the screen, please?
No, it's not up yet.
Oh. Oh. Mm. I'm having a few issues here. Okay, so it's not allowing me to share, but wow, I'm having a few issues with sharing my screen now, but not to waste too much time, let's quickly delve in before if the screen comes on. Well, as I said, when you come at the back of a very good presentation from doctor, it becomes quite tough to say much because he hit the nail on the head on most occasions. Basically, I think we were talking about satellite internet and its use in Ghana and then its advantages and why we have to use or why it has come as a very important thing to consider the use of satellite internet in Ghana. Okay, let's start with this. Let's say you go to a new place and then you wander into the bush, you wander into the woods, but you have your phone with you and then you are walking into the bush and all of a sudden it gets late. You turn back and you realize the path is about 5. You forgot your path. And you don't have satellite internet. You don't have internet, to be honest, and you're lost. There's no tower around that is communicating with your phone to give you internet. So you are lost in the bush or something. What do you think the solution is going to be? Definitely is going to be you having satellite internet. So once you have satellite internet and you are lost in the bush, voila, I think everybody can find you and you can call anybody and tell them, look, I'm lost here. I'm sending you location. Come for me. So it's become quite imperative that we add satellite internet to our modern day lives and as a solid backup for our already existing systems. So my name is Charles Dadzi. I'm from Galaxy Aerospace. It's always a pleasure to have audience listen to you, especially when we talk about space stuff and the fact that there's a lot of space activities going on in Ghana, which is very exciting. So when you talk about satellites, Galaxy Aerospace will definitely pop up. Now let's delve into Starlink, or let's talk about satellite internet, the inception and the reason why it came. So as Doctor said, we have the geostationary orbits where you have the bigger satellites doing a bigger space and covering areas like Africa. We only talk about digital satellite television, which is DSTV. And we have the low Earth orbits like the Starlink and the QPS, which cover a lower distance and reduce latency. And the reason why the likes of, I think when we were young, we used to see these adverts on CNN through our phone, and they're all excited. I was excited as a young boy. I was like, I want to use through our phone, stand on the desert and make calls. It was one thing that got me excited a lot when I was young. But growing up, it fell out of place because of the use of the geostationary satellite. You know, when you're in geostationary, you are covering a larger place, and so you have a lot of end users hitting up. So when you have a lot of end users, you know, a lot of data is being sent up and back and forth. So the satellite begins to suffer, and then you know it becomes a bit slow. Now let's zero in on, or let's even talk about what Google also brought. I think Google also brought on the Loon project. That is them sending balloons into the stratosphere, which is around 80 kilometers away from Earth. They send transmitters, and you know, 80 kilometers is even shorter than the low Earth orbit, which is usually in between 350 kilometers to 1,250 kilometers. So at 80 kilometers, you can imagine how fast it's going to be and how cheaper it's going to be because you're using balloons. But the issue with it is after 200 days, because the balloon was light, the winds used to blow it away in the stratosphere. You know, once you're still in the stratosphere, you are exposed to winds and all that. So after 200 days, then they lose the balloons and the transmitters. So they decided that, look, you know what, let's do this. If we study the weather, we can know where the balloons are being blown to, and then we can also send the internet to where the balloons are blown to if they need it. So they try to change the disadvantage to being advantage. So if you could remember, there was this cyclone, you know, what was it? A hurricane in Puerto Rico. That's, I think, Hurricane Maria or something. Yeah, Maria, around 2012. So I think there were about 100,000 people displaced with no internet. So the Loon project was sent in, and wow, it performed marvelously. I think it sorted out their issues. So it looks like a satellite internet is like the god of internet. Should I put it that way? Well, for me, I believe internet service has become I mean, it's a kind of fundamental human right. I believe everybody should be connected to internet in one way or the other. If you are not connected to internet, then I don't see you as being part of the world, because transactions, calls, I mean, everything now depends on internet. So if you don't have internet, I feel your space and the people who are taking charge of your space are not helping. If you compare the likes of South Korea, who have about 96 to 98% connectivity, and you look at the likes of Central African Republic, of about 10%, 15% people having internet. You can imagine the speeds at which development will take place. So internet has become a fundamental human right, and I think it should be part of our systems, and I think everyone should have it. Okay, now back to Starlink. So Starlink and the low Earth orbit satellites are, as I said, within the ranges of 350 kilometers to 1,250 kilometers, if I should say. And they are running at whooping speeds of 17,500 kilometers per hour. And you are asking yourself, if a satellite is moving at this speed, how is it providing internet? Because it's passing and going. So if I have my dish here, which we call it the Dishy. I mean, Starlink's dish is called Dishy, or Dishy Mac flathead, because it's got a flat head. And you have this satellites in low Earth orbit running away at 17,500 miles per hour. how do you still get internet? How do you maintain internet? Because it just passed by. So what's going on here? How is this worked out? I always look at this engineering as an engineering masterclass. Sometimes I ask myself that, is it that they leave the things there and then the next morning they come and then God has fixed it? Because sometimes you sit down and look at the system and the steps that are designed to give you this internet, you'd even appreciate it than the work is doing. So I'm like, okay, the internet is the satellite is passing. I have the dish. The dish has also its range. That it's this radius that it's trying to get the information from the satellite. So for us in space, obviously, I'll have to talk a bit more about space as we enter into the satellite. Now, at that speed of 17,500 miles per hour, it is doing one revolution of the Earth in 90 minutes. Right? So at traveling at the speed of 17,500, you'd have done one revolution of the Earth in 90 minutes. So the satellite, as it passes, so I'm talking about Starlink now. So as it passes the Starlink dish, it has sort of a maximum time of 4 minutes to be in that space. So the satellite from up is also sending signals to the dish down. So it is within a space of 4 minutes that the dish, that the satellite will pass. So after 4 minutes, when the satellite goes away, you don't have internet, right? So this is a question I want to ask audience, and I'm sure once you get it, there will be a Galaxy t-shirt for the person. So if you are doing, say, 4 minutes within the space, right? How many satellites do you think should follow up exactly enough for the first satellite that passed by to do another 90 minutes and come and provide the internet? Because you need to maintain internet throughout. So after 4 minutes, another satellite should just come and replace the next one. So after another 4 minutes, another satellite has to come and replace the second satellite. Right? So if you are doing a 90 minutes revolution, I'm asking, or Christabel, you want to answer, how many satellites will then have to go through before the first satellite comes to provide the same internet service? Okay, so we are looking at probably, if you do the maths, you're looking at about 24 satellites. So usually when you watch,
Approximately 23 satellites.
yeah, 23, 24 satellites,
We have
exactly.
22, we have 22 point something approximately because of the approximation 23 satellites.
Yes, good. So when you usually watch these space launches and all that from SpaceX, they are usually launching 24 satellites, 48 satellites, because those 24 can take care of an area. So they are doing the revolution around, and they're going up and down, and they are taking care of a particular area. And these satellites are linked with lasers. So it provides a solid structure for you, and it's strictly in orbit, right? So it's constantly giving you internet. So once you have 24 satellites hovering around you and doing that revolution in 90 minutes at 17,500 miles per hour, you are constantly getting your internet, and it's never interrupted, right? So that brings us to the fact that we have, you always have that internet service provided from the ground station to the satellite and to you. Okay, so basically that is how Starlink operates. Now, the little disadvantage about Starlink is probably, as you said, adverse weather conditions like solar flares and something we call the Kessler syndrome. So the Kessler syndrome has to do with coalition of satellites. So when you have a lot of satellites in low Earth orbit and there's a lot of, it's densed up and it's very tight, you might have coalitions. And once you have collisions, you have space debris. And when you have space debris, once you are close to the earth is pulling on you. So they do not have a fixed orbit. So they are just going up and down and doing their own thing. And then you have more crashes, and then space becomes very difficult to go. So for us, sometimes we become worried. Sometimes we space explorers and space lovers, we become a bit worried about that. But then the risks are quite low, and we believe that those things will not happen. So basically, that is about Starlink and its operation and how it works around in space. I think Doctor said a lot that is quite similar to what I also decided to say. Apart from the fact that we have a limited time, it would have been fun. There were a lot of technical things that, and I believe that there are a lot of technical guys on board that it will be fun to learn more and listen more on that. A few facts about the Starlink dish is that embedded in the Starlink dish, there are 1,280 antennas. So you can imagine the frequency, the wavelength that is going on in there. It's so amazing. The engineering is very interesting, and I believe that in a more better time or more extra time, we'll talk more about its technology and the fact that it is quite necessary that we use it. I can see a lot of hands there. We can go on and take some questions, please.
Yes, thank you very much, Charles. Yes, it's good for us to use, but the question is, can we afford it? With the figures doctor was mentioning, I hope that once they are in full force, we will be able to afford one in our homes. Okay, so we'll go to the questions. Charles, I see your hand is still up. Can you just unmute and then you can ask your question? Hello, Charles. Can you hear me? Okay. I don't know. It seems he's not able to. Okay, so we can go to Televerse International, or is it incorporation? Televerse. I will just enable your mic.
Yeah, thank you. This Televerse Inc. Incorporated.
Okay.
Yeah, so
Yes, please go
a
ahead with
month,
your question.
yeah, thank you. A month ago, we saw that satellite applications have been approved by NCA, right? So I want to ask Doc, at what stage of the licensing did we get this kind of approval? So you have seen the lineup of licensing that you listed, right? Quite a number of them. So when we saw that the news that Starlink application has been approved, right? At what stage of the licensings were we at? Thank you.
Okay. Thank you very much. So let's take it this way. You send an application that you want to have a driver's license, and then DVLA is happy with you, so they say that they accept your application. So now let's sit down and then iron out your responsibility. So essentially, we are happy with you. We are going to allow you to work. That is that communication about the approval. Now, as I mentioned, is about getting the processes right, reading out everyone's right and responsibility, what has to be done, and so on and so forth. And I said it's a contract, it's a legal thing. So everyone is very careful what you are going to do, what you are going through, and so on and so forth. Okay.
Okay.
Beside that, there are other works that are also ongoing by the SpaceX themselves in the country. So there's a lot of work that is ongoing. Yeah, thank you. I hope that was clear.
Yeah, very clear. And just a follow-up question. What is the tentative timeline for, like, from your point of view, for operations to start?
I'm sorry, that question, I cannot answer that question here, please.
Okay. Okay. All right.
Yeah,
Thank you.
thank you. Yeah.
He's not representing NCA in this forum.
Okay.
All right, thank you. So we now go to Keja. So Keja, if you can unmute and ask your question, please. Hello. Oh, I'm not sure if they can hear me.
We can hear you. I can hear you.
Yeah, you are audible.
Okay,
Yeah.
thank you. So then, Alfred, you can ask your
Okay, thank
question,
you.
please.
Yeah, thank you very much. This question goes to the Starlink revenue. As in May, I don't know how true this one was. There was a Google form seeking for Ready Master Starlink installation for free. We're asking installers and potential installers to fill a Google form. I don't know if you can speak to that, if it is authentic from Starlink and how far that one has gone. And then my second one is, as Starlink is coming, do they have any research grants for students or people who are interested in the research areas that they may be interested to establish their grounds in the country? Thank you.
Okay, Alfred, thank you for the question. Well, so Galaxy Aerospace is sort of spearheading is in the process of spearheading the use of Starlink in Ghana, pending regulatory rules and regulations. But once it's about to start, we as a company or as an agency wanted to offer training for installation of Starlink dishes. It's a DIY system. You can do it yourself, but there are certain places where the installation might need a bit of technicality and all that. So it's the form for installer for Starlink is under Galaxy Aerospace. So Galaxy Aerospace, we even had a webinar yesterday talking about the installation of Starlink and how the process of being part of the installation process and the training that we are going to offer. So it is not a fake thing. It's from Galaxy Aerospace, and it is not something that is linked to Starlink. It's linked to Galaxy Aerospace. It has nothing to do with Starlink. We are the ones training people because we have the training already. Basically that. And can you clarify the question again, please?
Yeah. So the second question. The second
Oh,
question
go
was
ahead. Yeah.
was about us. They have come in and Galaxy Airspace assisting them. Do we have research grants for students who are interested in research areas that your company might be interested in? So that people who are interested in conducting research, maybe either MPhil or PhD or undergrads who are interested in research areas that might benefit you? Do you have research grants and interest areas for such students? And based on what you said about the Google form, so those who have filled the form, should they, and I've not heard response from you, should they still expect someone like me? Thank you.
Okay, thank you. So when you talk about research, it is open to all, right? We are Galaxy Aerospace, as I said. I don't think you've heard us launch anything or do any launch as in a rocket. We've done a lot of projects. We've launched balloons. We've done space elevator projects, all in Ghana. We've had collaborations with German University and all that. So as an institution, Galaxy Aerospace, we also saw the need for things like this, like the expansion of research, doing your MPhil, doing your MSc and all that. And we have something coming up, our aerospace school, that will also encapsulate some of the big space agencies like SpaceX, which we are still in conversation with. So yes, there's something very huge coming up when it comes to space exploration in Ghana with Galaxy Aerospace. So yes, we have these research grants, and you have the opportunity to also contact us to have certain discussions like this with us. So yes, it's open. We're always grateful to hear from people like you to improve upon our work and make it easier for us to go. And yes, with the Google Forms, you haven't heard from us because we are still in the setup stage. We just want to gather the number of people, and then we know how we are going to run the training processes like. Okay, thank you.
Okay, thank you. Okay, we'll take our next question from David. David, go. Hello, Mr. Go.
Hello, good evening. Can you hear me?
Yes, we can. Good evening.
Thank you very much, Christopher. Thank you, Doc, and thank you, Charles, and the entire team. I'm really learning a lot this evening, and I'm really getting a lot of information about satellite internet, which is really good. My question is to Charles. You mentioned that with more satellites being installed, there can be issues of collisions and debris and all that. We also know, at least from my experience from telecom, that the more users you get, the more you need to install more capacity. Are we not going to get into a point where the whole space will be overcrowded and we'll begin to have even satellites falling on our heads, or maybe creating another environmental issues that will affect us? Affect us humans on Earth. Where do we get to that will say, okay, now the capacity that's been installed now, we can't go beyond that? I also want just to say a big thank you to you, and co-founder of your organization, Galaxy Aerospace, Mr. Tabolo. Thank you all for the good work you are doing. Thank you.
Thank you, David, for the question. Yes, of course, once we are all interested in going to space, we will have issues with a lot of satellites. As I spoke about the Kessler syndrome, probably having space debris and all that. So what it is SpaceX, if Starlink wants to cover the whole entire world, every space of the Earth with internet, they need 42,000 satellites, which they intend to achieve by 2029. Now, The issue is because we are having Cupa from Amazon, right, also in low Earth orbit, and other ones coming on board. That is where the complexity is. So for SpaceX and their satellites, they have issued a statement that their satellites avoid collision. So they have installed sensors that can indicate if any satellite is getting closer than necessary, right? So it's just like the space station. Obviously, once it's doing revolution and it notices that there's a body coming, they boost up or boost down just to be careful and try to dodge all those things. It's a problem. It's a huge problem, to be honest. But what SpaceX is doing is, as I said, they have designed their new satellites to avoid collision, and we are hoping that they said in the next 5 years they would have done 12,000 satellites. That will still be safe to travel to space. We might not have those collisions, definitely, but with the 42,000, sometimes it's scary. But as you said, we never know about technology going forward. Maybe things might change. They might, as you said, they are upgrading, they are doing a lot of stuff to their satellites. I think we are even in Generation 3. And I believe that with the good engineering works that is going on, we will be able to avoid most of these collisions, hopefully. Thank you.
Thank you.
Okay,
Thank you.
thank you very much, Charles. So we'll take our last two questions. We'll go to KJ. KJ, I hope I have the name right. Okay, Jack. Kaja. Yeah, if you can hear me. Hello. Okay, Nicholas, please ask your question.
All right. Good evening, ladies and gentlemen.
Good
So yeah, I'm
evening.
Nicholas. Yeah. So my question would be that is there with this all these Starlink conversations, is there any opportunity for maybe partnership to distribute their satellite dishes to end users? For us that are in this forum, or something like that. Yeah, that's what I wanted to know, and if there is anything like that, and how can we, take advantage of such?
Charles, would you like to take that for us?
Yes, I'll take a part of it, and I think Doctor will take a part because I think it's a bit of regulations with regards to it. So as far as we're concerned, Starlink is the ISP, right? So they are already providing the internet service. So if there's anything, as I said, they are dealing with NCA on that level. Distributorship is, I think, is a general thing. That falls on the legs of SpaceX and Starlink. So if they are dealing with Galaxy now, and then they feel that, okay, we want Galaxy to be the sole distributor of Starlink, then everybody comes to buy from Galaxy, and then they can redistribute, right? But as I said, everything is in process. NCA is also in process. Galaxy and SpaceX have the agreements there already. That is our confidential agreement. We still are waiting for NCA to finish the regularization, doing their regulatory systems, and then we can fully come out and give a solid information on the next phase of how Starlink is going to be distributed or is going to work across the country. So I think I'll still wait on NCA's approval, final approval on a few things before we can solidly come out. That will be probably on our website or on our social media handles. We'll keep everybody informed. Thank you.
Okay, thank you for that. And also, this is just by the way, I'm a new member. I got approved to join. this institute I think in March. So I'm very new and I don't know so much about the IIPGH like that, but I don't know if there will be a time for new members who have joined to be given some orientation or any of such official.
Okay, Nicholas, not to worry. Please drop your number in the chat. We'll reach out to you and then we take it on from there. Okay?
Please come again.
Please drop your number in the chat. So we'll give you a call and then we'll take it up from there. Thank you.
Thank you.
But for non-members who would love to join, please visit our website www.iipghghana and be a member. So we will take some time for our executive director, David, to address us briefly before we close. So David.
Thank you very much. Thank you. I think we really enjoyed today's session. I want to thank our resource persons for the delivery. We really learned a lot today, and the purpose for this webinar, I think, has been achieved. At least we are all going back with knowledge and better understanding of the satellite technology and how it brings internet to us, and it's very fascinating. The Institute of ICT Professionals Ghana is a professional body of those in the ICT industry in Ghana. It's registered by the Registrar General, and we have membership across all the domains of ICT. It's an organization that focuses on capacity building from young people, graduates, professionals, and also support businesses and other organizations, civil society organizations in the space of ICT. We organize a lot of capacity building workshops, one being our quarterly webinars, and also other in-person workshops, conferences, and one of such conferences is our Pan-African conference that we organize annually with other professionals across the African continent. This evening, I'm just returning from Mombasa, Kenya. I'm currently in Nairobi, and we are preparing for our upcoming TICON African Conference, which is an annual conference of technology enthusiasts and professionals across the African continent. Last year, we were in Uganda. In 2022, we were in Zimbabwe. And this year, we are going to Mombasa, Kenya. We believe that as professionals, we don't only have to sit behind our PCs, we also need to network with other professionals and share knowledge, and also learn best practices across the African continent, and also use that to build our own capacity and help in the sustainable development of the continent. We also organize our own events in Ghana. Some of them, the Tech Job Fair, Tech Entrepreneurs Forum, Industry Academia Tech Dialogue, and many other events that we organize for professionals. In October, we dedicate the month of October and we use that for awareness creation in cybersecurity. And we do this in partnership with the Cybersecurity Authority. And as a professional body, we have members that work with various government agencies in shaping policies and other legislations that governs our space. We invite anybody who is interested in technology to join the institute. You can register online. I think the registration link has been shared in the chat. And then you will submit your details. They will be reviewed. And then you will receive a confirmation. You pay your annual subscriptions of 300 cedis. And then you join the institute and you'll be given a membership ID. We look forward to meeting you again. We want to meet everybody in person, if not possible, virtually. And we're also using this opportunity to invite anybody who is interested in the upcoming TICON African Conference, which is a Pan-African conference for ICT professionals in Africa. It will be in September, from September 25th to 27th. And we normally have, it's more of not just a conference, but also a place where we network, where we have a lot of fun, and we connect with others. Thank you very much, and looking forward to meeting you again.
Thank you very much, David. So you can follow us on all our social media handles, IPGH, on IG, Facebook, LinkedIn, YouTube. Thank you all very much. Thank you to our guests and our attendees. Have a good night.
Thank you.
Thank you.
Bye-bye.
Bye.